Okay, last class we discussed the data quality attributes, right? I think you remember the things what we are discussed. Right? So maybe while you are doing a research, definitely you need to think about those data quality attributes, right? Then only you are getting what are the expected outcome from your research, right? Otherwise, we cannot guarantee what is the output we are getting. It's actual thing, or that is not a that sometimes that's a that is not impact the society from the data what we are getting as a knowledge, right? So data quality is mandatory before you start your data mining or data analytic task, right? So then we discuss 5 or 6 attributes, right? Okay, I think I stop here, right? Am I correct? So we discuss up to this last class, right? Today we are I'm continue from that data pre-processing, right? So do you have any questions, or shall we move for the session today's part? If you have any questions, you can ask. Otherwise, I will directly move for the content what we are planning to discuss today. Any questions? So even for doing a final year research, they are focusing what is the quality of your data. So whether you are directly getting from internet or whether you are collecting your own data, right? So compare with these two. So once you do your research with your own data set you are collecting, they are more valuable thing, right? Your research have more value rather than you are getting from Kaggle or something, and they are doing some researches, right? There are so many online data sources, or there are so many uh, data bases or some repositories. They have so thousands of data, right? So if you are using those things, you cannot get what are the things, right? Sometimes that's the data they are collecting different from our content, right? Also, there are so many things we discussed last class, right? So you need to think while you are doing your research as well, right? So what type of data I need to continue my research, right? Okay, if you don't have any questions, right? Please let me know if you can't hear my voice or is there any interruptions, right? Because here there is a rain, I think, so maybe internet issues there, right? So if you have any issues, you can't hear my voice clearly, please let me know, right? Or my screen sharing is interrupt, please let me know, okay? Okay, yeah, now we will move for the data pre-processing, right? So each and everyone know pre-processing means before you do something, you need to uh, preliminary works we can do, right? Let's say, yeah, let's see. Maybe if you are organizing an event, right? Before the event, we are planning everything, right? So just think about the open day. So before you uh, invite the people, you need to think, you need to work hard, right? You need to organize the things, schedules, and there are so many things you spend your time and you can do the uh, pre preliminary works, right? The earlier you plan and there are so many things you have done, right? Then only you are success in the event, right? Similarly, if you are doing a data analytic or data mining task, first thing you need to do pre-process, right? So you need to arrange your data, right? You need to clean, right? There are so many things comes under pre-processing, right? So the one type of data pre-processing is data cleaning, clean the data, right? Data integration, data reduction, right? Data transformation. These are the four main categories or types of activities that involve in the data pre-processing, right? So now we will look at one by one more detail, right? That is what we are planning to discuss here, right? I think we need to give more priority for cleaning part, right? Other parts are just simple things, right? Integration, reduction, transformation means they are not difficult thing, right? You can easily understand, right? Reduction mean we can reduce the parameters, right? Or maybe we can reduce the columns or rows. It's depending on the features of the data set what we are using. Similarly, depending on the uh, attribute values, likewise, there are so many factors influence to reduce the dimensional reduction, right? Data reduction means we can reduce, right? Integrate means we are merge data together, right? Transform means you have one type of data you are converting into different type of data. Maybe you can convert the ranges depending on the purpose, or depending on your values, we can do something, right? So these are the other three categories, but in the data cleaning, it contains most important things, right? So the data cleaning is, we are giving more priority, right? So maybe you don't, definitely you are doing these things, right? But without doing this, you can't achieve anything, right? Cleaning part. Anyhow, you are doing these things, right? Maybe if you are collecting so many attributes, then you can find out the correlations between the attribute. Depending on the correlation, you can find out more highly correlated attributes, and you can omit some minimal correlated attributes you can remove. Likewise, there are so many things there for reduction, data reduction, right? Integration also, they have some scenarios. Based on that, we can integrate the data, right? Similarly for transformation, right? Definitely you need to focus more time for cleaning process, right? Without cleaning, you definitely, you cannot get whatever you are expecting, right? Just think about someone doing a research, right? He captured the data, right? He captured the facial data, right? The, let's say, employee facial data, right? So he maybe this is one type of data he can capture. That the his research is sentiment analysis, right? Just an example, right? Sentiment analysis sentiment analysis using uh, facial expressions of employees in a particular company or something. That is his research, right? So someone doing a research this way, right? Maybe his hair is there, right? Everything influence in this image, right? Another person, right? He take a photo, only his face, right? So what do you think about this one and this one? Hmm? What do you think? So definitely you need to clean these data, right? Which one you need to clean first? So, or maybe depending on this topic, which, let's say this is A, this is B, which one you need to uh, clean? It is mandatory. The cleaning process is mandatory for A or B. Tell me. Hmm?
Yeah.
Why? Why you are telling A? I need reasons, right? So you are telling something. Uh, why you need to tell A is the answer? Why? What is the reason for that? Tell me. That is what we need, right? We don't know what is the topic you are doing the research, right? So definitely you need to think these ways, right? Tell me. Someone says A. What about others? Tell me. 003. What is that answer? Lahiru.
So second one B.
So B, you are telling
Yes.
B, right?
Yeah, sir.
Why? What is the reason?
It's
Why
not a
you need to
clear
clean?
one, but not
Sorry?
understand. Not a clear one.
Okay. Yeah, 041. Tell me. Each and everyone tell me your answers. Or just comment the answer. Send me the answers for me for the chat. Do it quickly. Need to complete by today, right? The content. So do it quickly. The slides I need to complete by today. So tomorrow also I will conduct a lectures, right? I think you have a free time in the evening. Right? Maybe I will conduct through our session tomorrow. Okay, send me the answers. B. The question is which A or B you need to apply more cleaning process, right? So, or maybe this type, this way. It is mandatory to clean the data, image A or image B. Which one you need to uh, apply more cleaning process, data cleaning process you need to apply for A or B. Just think about the topic as well, right? Sentiment analysis based on facial expressions, right? Facial features, right? So which data definitely you need to clean. So it means person A collected data this type. A has collected this type of data, B collected this type of data. Which data set you need to clean more? Yeah, someone says A. What about others? Just put your answers quickly. Just think, there's nothing, right? So the topic is sentiment analysis based on facial expressions or facial characteristics or features. Yeah, very good. Someone tell the answers, right? What about others? Just put your answers. Just send your answers for me. I'm expecting the reasoning, right? That is what we need. Other than answer, if you are selecting something, you need to tell why I'm selecting that one, right? That is what I'm expecting. So someone says B, B, yeah, 90, A, because we, yeah, very good. Yeah, ICT 09, yeah, 090, 090. Yeah, your one is correct. Answer is correct, right? Exactly. The reasoning also fine. 41. 41, that is not the reasoning, right? Yeah, 68. Yeah, your answer is correct, but I don't know what is the reason you're selecting. 29. Yeah, very good. Yeah, 29, your answer is correct, right? Your reasoning is good. Yeah, very good. 47. Yeah, very good. 47 also, your answer is correct, right? Yeah. What about others? Just tell me, right? Whether it's right or wrong, tell me, right? 04. Yeah, very good. It's your reasoning also correct. 68. 68. Your answer is wrong, right? Yeah, it's fine. Yeah, that is not a reasoning, right? You're telling picture B is clear while considering A, right? So it means what? Just think. I'm asking you which image data set you need. Definitely, it's mandatory to apply the cleaning process. For another data set, you don't need to apply more cleaning process. For which one? That's a question, right? Yeah, very good. 65, you are saying cleaning. Yeah, very good. A, need to clean, right? 68. Yeah, very good. What about others? I think very few people tell the answers. I don't know what about others. So definitely actively participate in my lectures, right? Then it will helpful for your career. Right? Even if you are an expert on this field, definitely you have a job opportunity in the market, right? Even in the industry or academy, yeah, you have so many opportunities for data science related things. Right? So just think about this, right? The answer is A, right? Why I am telling here, my research topic says I need to analyze the sentiment based on facial expressions, right? So facial expression mean I need to think about the chin and that eyes and that iris. Likewise, those are the things I need to consider, right? So if you look at this picture, I don't need to think about this body and the remaining things. Why? If it is an image data set, right? If I use the entire thing, right? The machine learning or data science, machine learning in the sense, they will learn from the data we are passing to the model, the algorithm, right? So that feeding the data from that data, what we are feeding, they will learn, right? So if you are feeding the entire image, what will happen? If they will think, right? Let's say if you are in the feeding time, we mentioned this is a sad image, right? So they will identify if it is a sad, the colored area also it need, then only we can say sad, right? So, but if you think about in my research topic, there I'm clearly mentioned, I know I need to use facial features only, right? So maybe the iris, and this is a correct way of collecting image, right? So if you are using this type of image, definitely you need to apply more data cleaning works, right? So it means we are not using a different data set, or we are not collecting different data set for our research. From this type of image, you can apply some pre-processing techniques, image processing, right? That's why there is, I told you, learn image processing techniques, right? So if you are an expert on image processing, they have so many libraries and there's so many functions. By using that functions, you can extract this oval shape, facial shape from this image, right? So definitely here you need to do the data cleaning part, right? So the data cleaning means Yeah, there are so many things included, right? Apply to remove noises and correct inconsistency in the data, right? Cleaning, right? So I don't need to explain more about cleaning, right? Clean means you can formatting your data set, right? If you have any mistakes in your data, then you cannot directly apply the data mining task, right? First thing you need to clean the data, right? So you need to proper formatting your data. That is why we are calling cleaning the data, right? Integration means I already told you, merge the data from multiple sources, right? In this integration in the sense, right? Sometimes what will happen, yeah, just think about in Oliveville area, right? Yeah, in Oliveville city, I just imagine, yeah, someone doing a research related to diabetic patients or diabetic patients or diabetic related research, right? So for that purposes, right, just imagine in the Oliveville area, there are two hospitals, right? Government hospital, in one in Atalachena, one in Akrapathu, right? So just imagine, right? I don't, yeah. Just imagine there are two government hospitals in this Oliveville area, right? So your target population for your research is Oliveville, right? So if you're at that time, right, just think about your targeted population is a particular area in the Sri Lankan map, right? So just imagine your target is Oliveville area, right? So now you need to think about all the patients are coming from the Oliveville hospitals, right? So if you are pick, let's say in here we have three hospital, right? Hospital 1, hospital 2, hospital 3, but you are only randomly picking one hospital and you are doing some data mining works. And if you do some findings, that is not impact your entire population, right? So you definitely you need to pick all the patients comes under these three hospitals, right? So at the time, right, there are three hospitals, no? So three hospitals maintain different record. We don't know they all the three hospitals are maintaining same type of database or patient record system, right? We cannot guarantee, right? So what you need to do, you need to visit each and every hospital, right? Sometimes just imagine hospital 1, they are maintaining that glucose level, glucomine level in the blood sugar level, we can say blood sugar, milligram per mole, right? Milligram per mole is one type of scale to measure. Similarly, another type of another type, yeah, there are so many, I don't know exactly, right? One is milligram per mole, another one is different, I just find out, right? So this hospital using different scale to measure the glucose level in the blood sugar, right? Blood sugar level, right? So now if you are collecting the data from these three hospitals, what you need to do, one hospital, your one column contain milligram per mole, let's say this is 120, 180, 135, likewise, it will goes one column, right? Here you have 100 patients. So 100 patient records are comes in this way. In hospital 2, they are using gram mole, right? So definitely this value comes as a 1.2 or 1.8, likewise, right? Maybe 2.5, 3.7, likewise, it will come, right? This is another hospital, right? Now, at the time, if you are collecting all the three hospital, you cannot directly merge this data, right? Because here our column is same column, right? Glucose density in the blood, right? That is the attribute we are collecting. If you look at here, this attribute have different range of values, right? But similarly, if you look at the hospital too, they have different range of values, right? So if you directly integrate these two hospital database or hospital records, definitely your algorithm or your model you are developing throughout this data set, it is not an efficient one, right? Because there are some variation, right? So at the time, if you integrate the data, you need to check some parameters, whether they are in the same scale, or you need to think so many things, right? So that so what you need to do for the solution for this one, maybe you're converting all the hospital records into milligram per mole, or maybe you are converting all the hospital records into gram per mole, right? You need to keep one type of attribute value, one type of scale to measure the particular parameter. That is mandatory, right? If you are using different parameters, that what will happen? your machine learning model, they are learning. Once you feed the data, they are learning throughout the what are the information you are passing, right? So if you are passing two type of information, it will understand in different way, right? So if they understand different way, then it will impact on the predictions, right? It will not give you a accurate predictions, right? So while the time you are integrate the data from different data sources, you need to think these type of things, right? So the reductions means we can reduce the parameters, right? So let's say we have 500 parameters. We can't use 500 parameters, right? Among the 500 parameters, we need to pick most uh, related parameters, most impacting factors, most impacting attributes for that particular domain. We need to pick some parameters, right? For that purposes, we are using correlation analysis, right? Just you can learn what is correlation analysis if you need to get depth knowledge, right? Correlation analysis, right? Just search about this one, right? Okay, yeah, data reduction. Also, just think about PCA, right? Anyone heard about PCA in data science related thing? What do you mean by PCA? In this data reduction, you have a knowledge on these and these, right? Then you're getting some more knowledge about your research area, right? PCA means principal component analysis, right? Principal component analysis, PCA. It means at some situation, right, we have thousands of parameters, thousands of attribute. We cannot use all the 1,000 attribute to apply or to use those 1,000 attribute for predictions or for model training purposes, right? So at that time, we can apply some principal component analysis. The functionality of that principal component analysis, they are without changing the behavior of that attribute, it will reduce the number of attributes, right? Let's say in your case, you have 1,000 attributes, 1,000 columns are there. Then you are converting these 1,000 columns into 50 columns. The important thing here, you have 1,000 columns, right? Here 50 columns, right? It means the principal component analysis, if you apply the principal component analysis, the behavior of this data will not change, right? The same behavior included in this 1,000 columns, similarly for the 50 columns, right? That is the functionality of PCA. Principal component analysis means without affecting the functionality of your data, without affecting the behavior of your data, it will reduce the number of attributes, right? So if you need a vast knowledge, you can search on the internet, right? There are so many online resources are there. Then also you can learn those things, right? So this is not a syllabus, just I tell some keywords, right? If you are an expert on this, it's very helpful for your research while you are doing, right? So just search about this correlation analysis and PCA, right? So the data transformation means just think about, we have, let's say we have two parameters, right? Their age and their salary attributes. Or maybe based on that, we can say employee category, right? Employee category, right? Senior, middle level, junior. Likewise, they are categorized based on their years of experience, right? This is not age, years of experience. How many years they have experience? Years experience, let's say their salary. So years of experience, maybe maximum 30 years or 35 years. That is the maximum value. Maximum 0 or 1 year to 35 or 40 years, they have experience, right, up to their age, right? If you think about the salary, maybe their salary starting from 200,000, right? 200,000 from maybe 20 lakhs, 20, yeah, 2,000, yeah, 200,000 to 2 million, right? 2 million, they have salaries, right? So based on that, they have senior or junior, we can categorize, right? So if you think about the range of these attribute, right, maybe 0 to 30 is the range, right? If you look at this range of the salary attribute, they have 200,000 to, yeah, 200,000 to 2 million, right? So if you look at these different types of range, because of that different types of range, what will happen? Your predictions also impact, right? So normally the procedure, while you are apply some data analytical things, you can use the same ranges for your attribute values, right? So normally, give me a minute. I headphone, right? Change the headphone, give me a minute. Hello, can you hear me? Hello. Please, someone response. Can you hear me?
Yes, sir.
Yes.
So normally what we are doing here, right, we can convert the parameters, right? We are transform the data set into uh, different ranges, right? If you have a different range for your parameters, normally what we are doing here, we are convert the parameters into the same type, right? So sometimes we can convert the parameter into 0 to 1 range, right? So we will look at how we are uh, convert the parameters into, let's say if you have a, let's say, just imagine there is a column called your marks, right? Your marks. There is a column marks for maybe someone 85, someone 92, 55, 42, 38. Okay. Now I'm asking you, right? So what is the range of these marks? 38 to 92 is the range, right? This is the range, actual range, right? I'm asking you to convert this into, yeah, 0 to 10 range, right? This is my conversion, transformation. So how you can convert? So just you can directly, maybe here we know the marks starting from 0 to 100, right? So if you need to convert this into 0 to 10, maybe you can divide it by 10, right? So then what will happen? 0 divided by 10, 0. Then 100 divided by 10, 10, right? Your range converted into 0 to 10, right? So now what will happen? If you convert this one 85, then it will come 8.5. This is 9.2, 5.5, 4.2. Here 3.8. Likewise, you can convert the parameters, attributes. This is called transformation, right? There are some equations to apply the transformation. We will look at those things a little bit later, right? Any questions? Okay, now we will move for the data cleaning, right? I already told you there are four major types of data pre-processing: data cleaning, integration, reduction, and transformation. Now we will move for the data cleaning, right? So inside the data cleaning, we are consider three major aspects, right? So if you are clean the data set, or if you are clean the data, means in the cleaning process, you are doing three things, right? So the first thing, you can fill the missing values, right? If in your data, if you have a missing values, how you can fill the missing values? That is the first thing you need to think about, right? Second thing, maybe normally in your data set, there are more possibilities to contain outlier values, right? The noisy data. So if you are keep the noisy data, and if you are doing some cleaning work, definitely it will not give the expected outcomes or expected predictions or findings from your data set, right? So you definitely you need to deal with the noisy data. Maybe we can remove the noisy data, or maybe we can apply some techniques and we can change the noisy values. Sorry.
The third one, correct the inconsistency in your data, right? In maybe there are possibilities in your data, different inconsistencies, right? So you cannot directly apply data mining techniques without applying or without changing the without doing inconsistency removal, right? Or inconsistency, you need to format the inconsistency into a correct way. So these are the three things we can do in the data cleaning, right? So what are the three things? First of all, you need to fill the missing values, you handle the noisy data, also you can correct the inconsistency in your data set. These are the three things you need to do in the data cleaning. Data cleaning is one of the major part in one of the major part in pre-processing is data cleaning, right? In the data cleaning, uh, the data cleaning, it contains three major functionalities: fill the missing values, smooth the noisy values. So to smooth the noisy values, you need to know the knowledge of Q1, Q2, Q3 quartiles, right? So based on the Q1, Q2, Q3, we can find out the outlier values. Maybe we can call outliers or noisy data. Both are same synonyms, right? Outliers or noisy data, we are considered the same meaning, right? So Q1, Q2, Q3, right? Quartiles, right? So then we need to find out interquartile range, Q3 minus Q1. So by using this Q3 minus Q1, they have some equation, right? So to find out the let's say you have 100 records, right? You have 100 records or 100 records of their weights, their weights. Weights of the particular area or particular school or something. You have 100 records, right? Definitely we have some obesity guys, or likewise there are some possibilities, right? So outliers mean they maybe because of some mistakes also they are record some error values, right? So to find out the outlier values for these 100 records, you need to find out the quartiles. Q1 you need to find out. First of all, you need to write all the 100 record in the ascending order. Then you can find out what is Q1, what is Q2 and Q3. From these three we can find out Q3 minus Q1, that is your interquartile range, right? Then to find out the outliers, there is an equation called Q1 minus 1.5 into interquartile range, right? So from this value to Q3 plus 1.5 into interquartile range. So this is one value, right? So now you know what is Q1, what is Q2, Q3. They are some values. So you need to find out if there are any values below this particular value. If there are any data points below these, then you can say that is an outlier. Similarly, is there any values above these particular equation, then we can say that is also a outlier values, right? So you need to check each and every data point whether they are comes under this range or above this range or below this range, right? So for each 100 records, you need to check, right? You need to check whether it's an outlier or not. How you can check? First, you can pick the first data point, right? You can pick the first data point, then you can apply you can find out this value, right? So you know Q1, so Q1 minus 1.5 into interquartile range, that is that tell a value that definitely it's a below Q1, right? So you have one value, these values, then you can check whether this data point 1 is below this or above this. Then based on these two things, then if it is not a below, it is not a above, then you can say this is a perfect data point, right? Similarly, you can check each and every data point one by one. If there are any data points above these Q3 plus 1.5 into interquartile range, we can say that is an outlier. Similarly, if there are any data points below Q1 minus 1.5 times into interquartile range, that is also we are considered as a outlier values. So this way we can remove the outliers, right? Now we will look at one by one how we can clean the data, right? The first thing we will look at how we can fill the missing values, right? We cannot apply the same way to fill the missing values for different scenarios, right? For different phenomenon, we can different situation, we can use different techniques to fill the data, right? So if you have any blank data, let's say maybe you are prepare a questionnaire, you can spread the questionnaire among the particular audience, you are getting some responses for your research, right? So at that time, we cannot guarantee all the responses are fully completed, right? Definitely someone they are not answer some questions, right? So we cannot uh, move furthermore by using this data, right? Definitely we need to fill the missing values. So now we will look at how we can fill the missing values in different situation, right? Altogether here, we have 6 different types of fill the missing values. We will look at one by one. Maybe based on this, you have a question, right? Maybe based on the questions, you have a CA today, right? Just look at carefully, right? Maybe I'm giving you 10 minutes to complete a CA based on that content what we are discussed today. So be ready for that, right? Share the news, right? Last time I give some excuses, right? Someone didn't attend the lectures and they will also submit the answers. This time I didn't check those who didn't participate the lectures and just directly submit the continuous assessment, right? I will consider about your attendance sheet and I will consider or not, right? So now we will look at uh, first type of situation. The first one, this is a one type of situation, right? We are ignore the tuple, right? Just imagine you have a table, right? You have a data set, right? So yeah, you have a data set, right? The temperature, humidity, yeah, temperature, humidity, uh, yeah, soil moisture, and some other parameters. Based on these, you are telling whether uh, today there is a rain possibilities or not, rain or not. Right? This is your class label, right? Now, sometimes what will happen, you have a missing values in the label data set. So now tell me, what is the label data set here? What is the label data set? If you think about temperature, humidity, soil moisturing, uh, the speed of the wind, right? Wind speed. There are so many things impact the rainy climate change, right? Wind speed. So just think about and tell me which one is the label data set. What do you mean by label data set? Where we can use label data sets? Tell me. Where we can use label data set? Anyone? Any volunteer to answer my question? So label data set means, right? So normally we have two types of machine learning tasks, right? First one, supervised learning. Supervised learning. The second one is unsupervised learning, right? Unsupervised learning in the sense you don't have any labels in your data, right? Just you need to find out the similarities between the data object. Based on that similarity, you can cluster, you are grouping your data, right? There is no label in your data. Just you can check the attributes of your data. Then you can, based on the attribute, you are clustering, right? You are grouping the data. That is we can call unsupervised learning. Supervised learning in the sense you have already a huge data set, the past previous data set, right? On that data set, they have the last attribute. Normally, the last attribute we are considered as a class label attribute. So the label attribute is the supervised learning in the sense you are predicting the values, right? You are predicting exact value or you are predicting some class label, right? So in this example, you are predicting whether the possibility of rain is yes or not, right? If you have this type of parameters, what is the probability you have a rain in the evening, right? So maybe you are predicting whether today there is a rain or not, right? So the label attribute in the sense, based on some parameters, we can tell whether you, let's say, based on your CA marks, based on your number of attendance, there are so many things. Based on that, we can tell whether you can pass the subject or not, right? That's also possible, right? That is a prediction. So supervised learning in the sense you are using a label data set. So in this example table, the label data set in the sense rain or not, that is a label data set, right? So in your table or in your data set, what you are collecting, if you have any missing values in this type of label data set, right? So the label attribute, normally that is the last attribute in your data, right? Or sometimes they're telling different attribute as a label attribute. So if there are any missing values in your label attribute, only thing, you cannot consider anything, just you can remove the entire tuple, right? So entire records you can remove, right? You cannot do anything, right? You cannot try to fill the missing values. If you have a missing values in your class label attribute, directly you can omit or you can ignore. You can remove that entire tuple. That is the thing you need to do. You cannot do any other things, right? If you have a missing values in your uh, label attribute, without considering anything, just you can remove the tuple, right? Remove the entire row. That is the thing you need to do, right? Maybe in your final exams, right? I'm giving you a table with different missing values, right? Then I'm asking you what type of technique you can apply to fill the missing values, right? So at that time, you need to tell why I am applying these techniques to fill the missing values, right? Let's say I am giving you a table. On that table, one column that is a label data set. On that label data set, you have some missing values. Then I'm asking you how you can fill these missing values. Only answer, just you can remove the tuple, right? So you have possibilities, that type of questions in my paper, right? So the second type of fill the missing values, you are manually fill the missing values. So first one, you can remove the entire tuple. Second one, you can fill the missing values manually. So manually in the sense, let's say you are share a questionnaire, right? Based on the questionnaire, right? While you are collecting the questionnaire, you can check, is there any missing values? Is there any unanswered questions in their questionnaire? If you have that type of questions without answer, then you can communicate with that particular person. Then you can manually ask, can you answer this question? Then definitely they will tell you the answer. Then you can manually fill the missing values, right? So that is we can call fill the missing values manually. By contacting that particular guy, you can fill the missing values. The disadvantage of this approach, it is a time consuming task, right? If you are doing a questionnaire with 10,000 employees, it's not a good it's not a big, it's not a simple thing, right? It's a big deal. You need to, if you have so many missing values, so definitely you need to fill the missing values manually. It's not feasible all the times, right? Okay, now we will look at the third type of fill the missing values. The third type we are fill the missing values. If you have any missing values, for that missing value cell, you are giving some specific names, right? Use a specific label. You are creating your own label, or you are creating your own constant value. Then if you have any missing values, for all the missing values, you can fill that particular keyword, right? Let's say sometimes you have a keyword called unknown, right? So if you have any missing values, directly you can tell, or you can replace that location as a unknown, right? That is the third one. The fourth one, we can apply the central tendency. So central tendency means you can apply the mean, median, mode values to fill the missing values, right? So you cannot apply the three things, mean, median, mode values, for all the situation, right? So different situations, we can apply different things. If you're already, we discussed different types of data, right? If you have a data, numeric data, definitely you need to apply the mean value. If your data set is a numeric value, number value, age, salary, likewise, then definitely you need to find out with the mean value. If you're or maybe you can apply the median value, right? But if you have a data set with a categorical data. Categorical data means maybe the nominal data, or maybe the uh, ordinal data, or the binary data. These are different types we discussed, right? Or nominal, ordinary, or binary data. Then we cannot apply the mean value, right? Because these are categorical data. We cannot apply mean, or we can find out the mean for these categorical data. For that type of scenarios, we can use the mod value, right? So yeah, I think, yeah, that is not mentioned here, right? So just include that one as well, right? If you have a categorical data with missing values, you need to fill with mod value, right? We cannot apply the mean or median because they are apply for the numeric data. Here we have a categorical data. Then, sorry, then you can apply the mod value. So these are the different techniques, right? So up to now, what we are discussed, the fill the missing values. Maybe you can remove the tuple if you have a missing values in the label data. The first one, the second one, what is that? Tell me. Manually fill the missing values. Third one.
The global constants.
Yeah, maybe you are using some global constant or global terms to fill the missing value. Fourth one, we are using the central tendency. Maybe if it is a numeric data, you are using the mean or mean or median value. If you have a categorical data to fill the missing values, you can use the mod value. Why I am explaining here, right? You are doing a practical with Vecca or Python. What you need to do sometimes, let's say maybe for your final exams, I'm giving you some questions with some missing values, right? So you need to find out the missing values and you need to fill the missing values. So at that time, you need to decide which type of uh, way I can fill the missing values. For that purposes, you need to know which type of data this one, right? So if I give you a data set for your final exams, I'm giving you some data set. So for the based on that data set, you need to do some task, right? Let's say I'm asking you to apply some clustering or predictions or some whatever. I'm asking you something. So you cannot directly move for the model development part, right? You need to move little bit little, right? Even if I ask you the final stage, first you need to check these things, whether is there any missing values. If you have find out any missing values, what you need to do, you need to fill the missing values first, right? If you fill the missing values, then only you can move for the next step. So at that time, if you have a missing values, first you need to analyze your attribute. What is this attribute, right? In the database table or in the table, I am giving you an explanation of your table. What is these parameters, right? So based on this, you can understand what type of parameter this one, whether it's a numeric or nominal or whatever categorical. So based on this, you are the one decide which type of pre-processing techniques you are using. So for that type of knowledge, you need to aware different filling, different techniques to fill the missing values. Okay, now we will move for the fifth one, right? Okay, the fifth one. Okay, yeah, this fifth one, right? Some situation happen, right? I will explain with the table, right? How to say? Okay, okay, just imagine, right? Okay, this is their salary attribute, right? I didn't explain entire table, right? This is employee salary and their category, right? Yeah, maybe their seniority category or something, right? Maybe someone salary for 450,000, maybe he considers a senior employee, right? Another guy 200,000 junior employee, right? Maybe uh 10 million, right? Maybe we are considered as a architect. Likewise, we have some data records, right? Okay, here we are telling only three, right? Maybe another guy 400,000, he is a senior, right? Another guy, we have senior but we don't know, this is missing value. Another guy, he is a junior, he have salary 150K. Another guy, he is a junior, he has 80,000, right? Another guy, he is a senior, his salary is 350,000. 1000, right? Just imagine you have a data set, right? So the fifth type says, right? The previous fourth type, what is the fourth type? If you have a missing values, this is a numeric data, right? This is a numeric data. So if you have a numeric data, in the numeric attribute, if you have a missing values, normal way, you get the mean value, right? So how you can find out the mean value? Tell me how you can find out the mean value. Tell me, someone tell me the answer. How you can find out the mean value? You get the sum of this when this value 400, 450, 200,000, 10 million, 400,000, 150, 80K, 100, 350K, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 employee salaries there. 8 employee data set is there right here. 8 employee data set is there, right? Now just you get the sum of these, right? 450K, 200K, 10 million means 1000K, right? 1000K, 1000K, plus 400K plus 100 plus 150K. Just imagine this is 150, okay? Yeah, this is 150K, 80K plus 350K, right? Okay, 450, 650, 1650, 1250, 250, 220, 2200, right? This is 450, 450, this is 650, 1650, 2050, 2200, 2200 plus 30, 350 plus 80, right? So the sum is what? 2600 and 2630 rupees. This is K, right? 2630K. Then divided by how many? So to calculate the mean value, how many? Is it okay if I divided by 8? Because I'm telling you the 8 employee data now. Is it okay? Tell me.
Sir, need to be divided by 7.
Yeah, very good.
No.
That is the mistake normally you are doing, right? So in the question, I am telling you, right? This is a table of 8 employees. So your mind fix. Okay, here there are 8 employee records are there, right? So here I have a one missing value, right? Okay, this is the missing value I need to fill, right? For that purposes, this is a numeric data. Because of it's a numeric data, so we need to fill the missing values by using the mean value, right? So you are the one decides which type of things you are using to fill the missing value. So you decided it's based on the mean value. So to calculate the mean value, you know that is a simple thing, right? You need to get the sum of all the attributes divided by how many total number of instances you consider, right? So here we are adding how many? 1, 2, 3, 4, 5, 6, 7 salaries. We are get the sum of 7 employee salaries, right? So if you are divided by 8, it's wrong, right? So you definitely you need to divide it by 7. 2630K divided by 7. What is the value? Approximately the average salary, the mean salary is 375K. It means 375,000, 3,75,000. This is his salary, the normal way. So this you need to fill this value with 375K, right? What will happen if you divide this 2,300 2,630 rupees divided by 8? You're getting different salary, right? So it is approximately 8 into 3, 24. Remainder is 2, then 23. So it is 2, 16. 16 means 7, 70, 78. So it considers a 328K. Did you notice this, the difference between these two? So if you do a small mistake, you are divided by 7 or 8, right? If you are divided by 8, you are getting 328,000 328,000. If you divide it by 7, you are getting the salary of 375,000. 375,000, right? So you need to careful about the things, right? So this is a normal procedure. You are fill the missing values, right? Here we are discussing some different techniques, right? Here the different technique is what? Use the attribute mean. Right? Just I will wipe something. Yeah. This is the normal way. If you have a numeric value, you can fill the fill the missing values by using the mean value, right? But this is a different scenario. That's why I'm explaining here, right? What is the different scenario here, right? Here, the missing values occurred for which type? Right? Just imagine, right? Here, the missing value occurred for senior category, right? If you notice here, this is my missing value occurred, right? So the fifth type says, if you have a missing value, you are not considering all the employee salaries and you can divide it by total number of instances and you are getting the mean value. That is not the way. If you have a missing value in a particular type of label, see here, the senior label have the missing value, right? To fill the missing value for this cell, you are considering only this one and this one and this one. So you are only consider all the senior category employee salaries and you can divide it by that total number of instances. It means you are considering or you are calculating the mean for that particular class only. For the only that particular class, you are calculate the mean value and you can fill the missing values, right? You are not consider the entire data set. You are consider only that particular category. Only the particular category you are fill. Yeah, give me a minute. Yeah, sorry for the interruption. Okay, so in the previous type, fourth scenario, you calculate the mean for the entire column and you can fill the missing values, right? The fifth type, you are not considering the entire column to calculate the mean value, right? If you have a missing value in a particular type of label, you are calculate the mean value for that particular label only. So if you have a missing value in the senior category, so you are only picking the salary of senior employees, right? So just you are picking this 450,000, the first column, this one, then you are picking this 400,000, 400K, then you are picking only this 350,000. 350K. So we have only three, no? So even if you have more number of senior category people, only you are considering those senior category people only to calculate the mean value. So here we have only three samples for the senior category people. So you are getting those three senior category pupils salary. Then you are getting divided by 3, right? Because we have only 3 data points. So you are getting divided by 3. Then what is the value? 400, yeah. 100,000, 200K, right? 450, 850, 912, right? 1,200K divided by 3. So the mean value is 400K. So here you are filled these 400K, right? In the previous case, we get the answer 375K, right? Why we are getting that one? We are consider all the category pupil and we are get the average value, right? That is not the way, right? Because if it is a senior category pupil, they have more salary, right? So that is we prove with this one, right? We are getting here 400K, right? So this is what we are telling here. Rather than you are using all the values, all the tuples, all the entire column and calculate the mean value, here only you are considering that particular type of label data set, right? Any questions? Any questions? So what I'm telling here, use the attribute mean or median value, attribute mean or median value for all the samples belongs to the same class as given tuple, right? That is the meaning of this sentence, right? So while you are calculating the mean or median value, you can apply only for that particular class label, right? So here only we are considering the senior category pupil, then you are calculate their mean value. By using that mean value, you can fill here, that is 400,000, right? So here they are giving an example, right? Classifying customers accordingly, credit risk behavior, right? Maybe the bank classify their customers whether credit risk or safe based on their past transaction, right? Maybe you are you are using a credit card, maybe, or maybe you apply for a loan. The bank have some ideas about your past behavior, right? Uh, the all the banks are connected with central bank, right? They have some systems to manage. Maybe you are already take some loans from some banks, right? Without disclose those information for a new bank, you can apply for a loan. So at that time, they have some scenario, right? They have some techniques to evaluate you whether if they are provide this loan, they can recover from you or not. It's a safe for them or it's a risky for them. To find out those type of things, right? So let's say we have some missing values in a particular monthly income or something, right? For that scenario, right, you are only think about only risky customers, right? Or maybe you are consider only safe customers. It's up to the number of labels you have in your label data set. Then you can consider that type for find out the missing values, right? The sixth one, you can use the most probable value to fill the missing values. Most probable value in the sense, maybe you can apply some regression analysis, or maybe you can apply inference based tools. There are some tools we can call, or maybe we can apply regression techniques. So, or maybe you can use some statistical methods, right? So statistical analysis, based on that you are predicting some value, so you can fill that value, you can fill with that particular value to fill the missing values, right? So maybe you can apply some regression model. From the regression model, you find out some values. For that values you can use, or maybe you can use some statistical approaches, Bayes theorem and other things. Based on that also, you can fill the missing values. These are the six different types of fill the missing values, right? So normally if you need to use this type, you need to mathematically prove, right? If you are using Bayesian formula, then you need to properly validate why I am using these, right? So mathematically you need to prove to use these Bayesian theorem or regression analysis or something, right? So up to the first 5, definitely you can use, right, without any proper validation. But for this one, you need some proper validation to use these techniques, right? So up to now, we are discussed 6 different types of fill the missing values, right? So what are they? What are the different types of fill the missing values we are discussed? Tell me. First thing, you can remove the tuple when you have a missing values in the class label. Second one, you can manually fill the missing values. Maybe you can use some global variable to fill the missing values. The fourth one, maybe you are using the mean value for the entire column. Fifth one, you can find out the mean value for the particular category or particular class label. Fifth one, right? If you have a fifth one, if you have a categorical data for this one, the mean value you are using for numeric data. If you have a categorical data, maybe that nominal, ordinal, or binary, on that situation, you can apply the mod value to fill the missing values. There are also 2 different types, right? Maybe you can find out the mod value. Yeah, you can fill the mod value, right? So if you have a categorical data, then you can find out the mod value of that categorical data. By using that mod value, you can fill the missing values. The seventh one, right? You can use the probability theorems and some mathematical formulas, Bayes theorem and other things you can use to find out the values. Then by using that mathematical finding, you can use that mathematical finding value to fill the missing value. That is the different types of fill the missing values, right? Any questions? Not only for the subject, if you have enough knowledge on this, you can do your research in a well proper manner, right? You don't have a you don't worry about the struggle in your defenses or in your interim or whatever if you have these type of knowledges, right? If you have enough knowledge on these areas, no one can ask you a question, right? You can argue, you can defense their questions, right? If you have a vast knowledge on that subject, no one can argue with you, right? So your research means you need to learn a lot, right? If you have enough knowledge, whatever the questions they are asking, you can easily uh, uh, answer and you can defend their questions, right? That is what we are expecting from you guys, right? Yeah, next one. Any questions? Okay, now we will look at how to fill the missing values, right? Fill the missing values. Second thing I already told you, you can remove the or handle the noisy values, right? Outlier values, right? Some situation we can remove the outliers. If you have a noisy values, we are not considering those noisy values. Let's say, I will tell you a scenario, right? Now, there are two types of scenarios, right? Scenario one, right? You have enough data set. Let's say you have collected 10,000 samples, right? You have 10,000 samples you are collecting for your research. Scenario one. Scenario two, you have only 500 samples, right? These are the two scenarios, right? Just think about this. One student collecting 10,000 samples for his research purposes. Another person for his research purposes, he have only 500 samples, right? So in their both data set, they have noisy values. Just think about in scenario one, he has 100 noisy data. Let's say he has 100 noisy values. Just imagine how we can find out these 100 noises, how he will notice in his data, there are 100 noisy values. Tell me how he will notice these 100 noisy values. Answer my question. Normally, I'm not agree to do the lectures online, right? I don't know whether you are follow with me, right? If you follow with me, then only I get the knowledge what I'm teach here, right? You don't know the value of this course module, right? If you are just search about in Colombo University or Moratuwa, they have some course modules, right? Data science with Python, right? So for I think once a week they are conduct for our lectures, right? You need to pay 35,000, right? Around 5 to 6 weeks they will cover the basics. You need to pay 70,000, right? They are not giving, even they are not teaching you this level, right? This much of things, right? They are giving that very very basic things, right? For that data science basics, uh, they are you need to pay around 35,000, right? Also, you need to visit every week. Just think about the cost. Here, we are giving you the free of charge, right? That is the benefit of free education, right? So don't waste your free education, right? Actual thing, if you get something free of charge, you don't know the value of the things, right? That is the thing happen in the state universities, right? The people who are studying in the private sector, they spend their money, right? So they know the value of their money, right? Each semester or each repeat subject, they need to pay around 20 to 50,000. Different places they are collecting huge amount of money if you have a repeat on one subject. Also, if, so they are paying the money, they know the value, right? So they spend more time, they are utilizing their time to pass and get the knowledge. But if here everything is free of charge, no, so free education, right? So you don't know the value of the degree you are earning here, right? That's why most of the students are very careless and lazy to learn the things and explore new knowledges, right? So tell me, I already teach you, right? Just imagine you have a two students, right? One student collecting some data, numeric data. Another student collecting some numeric data, right? Student 1 have 10,000 samples. Student 2 have 500 samples, right? My question is, let's say in the student 1, he noticed in his data set, there are 100 noisy values, abnormal values. There are 100 abnormal values or noises are there. How he will identify whether he has 100 noisy data? Tell me. Today I teach you. Hmm? Tell me. Yeah. Yeah, you close to the answer. What about others?
By calculating the central tendency or standard deviation of the particular samples.
Yeah, very good. So I give you an equation, right? Q1 minus 1.5 into interquartile range, right? So you first thing for the 100 samples, right? You need to find out the interquartile ranges, right? So there is a small equation in Python. So if you call that equation for that sample data, it will tell you, right? Yeah, interquartile range, right? So you calculate the interquartile range. Similarly, you can find out Q1, Q2, Q3. So okay, now you know Q1, Q2, and Q3 values as well, right? So now you are calculating this. Let's say this is, we can tell the M, right? Okay, yeah, just I'm telling this is a minimum value, right? Min is equal to Q1 minus 1.5 into interquartile range, right? So let's say, just imagine that interquartile range comes as a maybe 800, right? Similarly, the maximum means Q3 plus 1.5 into interquartile range, right? So for that one, you are getting, let's say we are getting 55,000, right? So this is the range for min and max, right? Now what you need to do, you can take each and every samples, you can pick one by one, then you can check whether that sample is between these two values or not, right? So you need to check whether the first data point between 800 and 55,000, then you can say that is not an abnormal value, right? Similarly, you can check all the samples for all the 10,000 instances. You need to check whether they have between these range 800 and 55,000 or not. If the above 88,000, sorry, if the above 55,000, that is we are considered as a outlier, noisy value. Similarly, if you have a below 800, we are considered that is a noisy value, right? So this is the way we can find out. In his data set, there are altogether, sorry, in his data set, okay, the student 1, he will find out 100 noisy values in his data. Similarly, the scenario 2, he find out in his data set around okay, around 50 noisy data is there, right? So in the noisy data, maybe we can remove the noisy data, or maybe we can handle the noisy data. There are two things we can do, right? Maybe you can handle the noisy data, or maybe you can remove the noisy data, right? When the situation you can remove the noisy data, you have enough samples, enough data set you have, right? Definitely you can remove the noisy data. You don't need to include the noisy data, right? So just think about, you have a 10,000 samples, right? You have a 10,000 samples. So between these 10,000 sample, 100 means what is the percentage? So 100 means that is a only 1%, right? In your data, only 1%, right? So in the 10,000 data, only 1% is noise, right? Similarly, just think about, you have a 500 data, you have a 50 data, they are noisy values. So if I get the percentage by multiplying 100%, so if you notice here, right, 50 divided by 5, so it is equal to 10%, right? You have your data 500 samples, 10% of your data, they have noisy values. Now just tell me, this is 1% you have noisy values, here 10% you have noisy values, right? So if you think these two, what is your decision? Whether you can remove the noisy data or whether you can deal with the noisy data. So in this scenario, maybe you can remove the noisy data because you have enough number of samples, right? You have 10,000 samples for your model training purposes. You have 10,000 tuples, right? So only 1% noise. So it is not impact the results. So because of that, you can omit these, you can eliminate these noisy values in your data set, then you can continue your remaining works. But if you look at these here, if you look at this here, there is a huge 10% of your data will remove. If you remove these noisy values, your how to say, your behavior, the data set behavior will impact in many ways, right? Because 10%, 1% is not impact your results, right? But if you look at the 10%, definitely it will impact your results. So if you don't have enough samples or enough set of data, what you need to do, you can deal with the noisy data. We cannot remove the noisy data. We have some techniques. By using that techniques, we can sort it out the noisy values, right? We will look at how we can remove, how we can handle the noisy values little bit later, right? So two things, maybe you can remove the noisy values or you can handle the noisy value. Handle means we are not removing that noisy value. We can do some mathematical things and we can convert that noisy value into some different values, right? That is handle the noisy value means, right? So you are the one decide whether I have enough data set. So then I don't need to worry about to remove. If you don't have enough data set, you don't remove some tuples. You definitely you need to anyhow you need to deal with that noisy values and you need to include, right? So one techniques to find out the noisy values, we have an equation with interquartile ranges. By using that equation, we will find out the noisy values. That is one way we can find out the noisy values. Not only that way, we have some other techniques to find out the missing values. Now we will look at what are they. Okay, the first way to find out the noises, we are using some interquartile range equation with IRQ, Q1 minus 1.5 into interquartile range, Q1, that equation, right? Interquartile range based equation, we can find out the outlier values. That is one way. Second way, we can plot the data set. We can plot the data set. Based on the plotting, we can easily find out. These are the two different ways we can find out the noisy values. It means if you have a data set, right, if you have a data set in your Excel sheet, we don't know about the behavior of your data, right? If you have a Excel sheet, let's say you have distributed questionnaire, from that questionnaire you are collecting the responses as an Excel sheet. We cannot take any decision about your data by look at your Excel sheet, right? Only thing you need to do, right, just you can find out the characters, right? One thing, if you need to find out the noisy values, right? For that purposes, you need to, first thing, maybe you can find out the interquartile range and you have that equation. So you can check whether how many records they have abnormal values. That is one way. Another way, maybe you can plot the data set, right? For that plotting, you have different techniques, right? Maybe you are using some bar charts, right? So for that particular column, right? Let's say in your data set, if you notice here, in your data set, you have n number of columns. There are different columns, right? Age is a column, salary is a column. It's up to your data set. You have different columns, right? Now what you need to do, you are picking only one column. For that column, you are plotting these type of bar charts, right? So let's say if you have a, let's say this is based on the salary attributes. Then you can plot. So once you plot these, right, you can find out these. You can easily find out the outlier values, right? Maybe if you have some data set, sometimes you have data set that is a unlabeled data set, right? Unlabeled data set. So at that time, unlabeled data set, if you have any unlabeled data set, on that time, maybe you can plot this way, right? Let's say you have two parameters, age and salary, right? So based on that, let's say this is related to clustering part, right? If you have a unsupervised learning, cluster grouping the data sets, so you can plot these two axis or three axis plotting, right? Histograms on three axis plotting. From that plotting also, you can find out the outliers. So what are the different ways we can find out the noisy values based on the mathematical equation with interquartile range? One way. Another way, we can plot the data values, data set, we can plot in the different graphs. Based on the plotting also, we can easily identify the outlier values, right? Then you can handle the outlier values. How you can remove the outliers or manage the outliers into convert the outliers into manageable form. Right now we will look at how we can handle the outlier values, right? So outlier means nothing, just the abnormal values because of human errors, or there are some purposefully they are giving some abnormal values. We don't know the mindset of the person who filled the questionnaire, right? Maybe sometimes they are purposefully increase abnormal values for something, right? Sometimes by mistake they are putting some zeros or something. We don't know the exact reason, but we can't do with outliers. We definitely remove the outliers or handle the outliers to get expected outcomes, right? Now we will look at how we can handle the outlier values, right? To handle the outlier values, we are using binning techniques, right? Normally we are using the binning techniques, right? So here we are look at how we are handle the outlier values, right? So the handle means smoothing the outliers. How we can smooth the noisy values? Maybe you can use normally we are using the binning techniques, or maybe we using the regression analysis, or maybe we are using the outlier analysis, right? So outlier analysis in the sense, outlier analysis means the plotting, right? Based on the different attributes, age and salary, you are plotting the columns, right? Maybe if you're plotting these, you have some distribution of your data, right? If you have some distribution of your data, so at that time, right, if it is abnormal value, they are far away from the normal distribution, right? So depending on the number of abnormal values and some other parameters, maybe you can remove those outliers, right? So this is regression analysis. So you are based on their similarities, you are grouping the data. At that time, you can easily find out the outlier values. So regression analysis means if you have a data points, if you have a data sample, regression means that is a linear equation, right? So if you have some this type of uh, data set, you can find out some linear lines, right? So these values are considered as outliers and we can remove, right? So it means you will find out some linear equation, right? I think you discussed those things in your practical, right? The linear equation calculation, right? Y minus y1 into m into x minus x1, or maybe y2 minus y1 over yeah y2 minus y1, this equation, right? I think you know the linear equation, right? Y minus y1 is equal to y2 minus y1 over x2 minus x1 into x minus x1. So this is a equation for linear equation, right? So regression model means you need to find out this type of equation. I think you discussed those things in your practicals, right? So the regression techniques or mathematical part, they will cover, I think, right? So if you don't cover, don't worry about that one, right? There are some regression model development techniques. By using that regression model development techniques, you can find out the linear equation, right? If you find out the linear equation, so all the data points are very close to that linear line, they are considered as a samples, others we can remove, right? So these two normally we are using the below these two techniques we are normally using to remove the outliers, to remove the abnormal values, remove the outliers. The binning techniques we are using to handle the outliers, to handle the outlier values, we are using the binning techniques, right? So the regression or outlier analysis means that clustering, this one. Regression means regression, they are not mentioned here. This is called outlier and outlier analysis, grouping the data points. Regression means we are find out some linear equation, right? So now we will look at binning techniques. So binning means we are sort out the abnormal values in the proper way, right? So now I will explain how we apply the binning techniques, right? Sorry. Okay, now I will tell you how we can do the binning techniques, right? So, okay. Yeah, now I will tell you there are two types of binning techniques, right? Binning based on mean value, binning based on the bin boundaries. Or one type of techniques, smoothing by bin mean value, smoothing based on bin boundaries. Okay. Okay, this is just a dummy data, right? Okay. Yeah. I don't know whether we can apply for this data, right? So the normal procedure, right? I will tell you, right? Okay. Yeah. So the normal procedure, you have an equation, right? You can find out 2, 4, 6, 8, 9 values. So n is equal to 9. 9 data instances are there. So Q1 means n plus 1 divided by 2. So 10 divided by 2, it means fifth value. Fifth value means the Q1 is what? Fifth value means 21. So 21 is your Q1, right? What about Q2? Q2 n plus 1, sorry, this is Q2, right? So Q1 interquartile, Q1 means first quarter, right? N plus 1 divided by 4, right? So it means 10 divided by 4, 2.5th value. So 2.5th value means 2.5th. So this is second value, this is third value. So the 2.5 means you can get the sum of 8 plus 15 divided by 2. So 23 divided by 2, 11.5 is the Q1. So you can find out Q1 as a 11.5, right? Just I will practically explain, right? Just imagine this is your data set, right? This is your data set. This is your data set. Because if we have a huge data set, we can't explain, right? So first you can find out the Q1 11.5. Now you know the Q2. Q2 n plus 1 divided by 2. N is equal to 9 plus 1, 10 divided by 2, fifth value. So the fifth value means Q2 is equal to, fifth value means 21 is a Q2, right? So Q1, we know the Q1 is 11.5. Q2 is 21. So similarly Q3. Q3 means 3 into n plus 1 divided by 4, right? 3 times 2.5. It means that is a 10 into 3, 30 divided by 4, 22.5. Sorry, that is not right. N is equal to 9, 9 plus 1, 10, 3 into 10, 30, 30 divided by 4, then 7.5th value. 7.5th value means 2, 4, 5, 6, 7. 7 this one, 8 this one. So the 7.5 means get the sum of 25 plus 28 divided by 2, 53. 53 divided by 2 is equal to 26.5, right? So your Q3 is equal to 26.5, right? So then you can find out interquartile range. So Q3 minus Q1. So Q3 minus Q1, 26.5 minus 11.5. So 15 is the interquartile range. Am I correct? So interquartile range is 15, right? So this is a normal procedure. You can find out Q1, Q2, Q3. You can find out interquartile range. So then you can find out the minimum value. So what is the equation for minimum value? Q1 minus 1.5 into interquartile range, right? This is a normal procedure, right? So Q1 is equal to 11.5 minus 1.5 into 11.5. So 1.5 we can write as a 3/2, right? So 11.5 minus here interquartile range 11.5. 11.5 into 3, 33. 34.5 divided by 2, then 17.25, right? So then if you subtract, it comes as a minus, what is the value? Tell me. Maybe 2.5 is there. 6.25, right? So if there are any values below minus 6.25, we are consider outlier values, right? Similarly, you can find out the maximum value Q3 plus 1.5 into interquartile range, right? So then you are getting some value, right? What is the Q3? 26.5 plus 26.5 plus 1.5 multiple by, that is the same value, right? 17.25. So then we can say around 26, 36, 43, 43.75 is the. So if there are any values above 43.75, we are considered as a abnormal values. So someone says IRQ is 15. Yeah, I forgot, right? Sorry. Yeah, sorry for that, right? So the interquartile range is 15, right? Yeah, I forgot. Yeah, very good. So I need to replace here by 15, right? So yeah, very good. Here, if I replace by 15, 26.5 minus 11.5, 15, right? So 45 divided by 2 here, right? 45 divided by 2, 22.25, 45, right? So 22.5, right? So if I subtract this one, so what is the value?
11.
Minus 11, right? Minus 11. That is important. Here also 1.5 into interquartile range. Here I need to get the sum of plus 22.5, right? So the maximum value consider as a 26.5, 22, 48, 49, right? So is there any values above 49, we are considered as a abnormal values, right? So that is the one way. Now we are planning to pin, now in this data set, there is no any abnormal values, right? Actually, there is no any abnormal value, right? So if it is abnormal value, right? Just imagine, let's say, yeah, in your data, this is not a actual data, right? Just an example I'm giving you. This way I can find out the abnormal points, right? But here there is no any abnormal points, right? So it becomes an abnormal. What you need to do here, in your data set, there are some sample points above 11, right? Above minus 11, right? Minus 20 or minus 10. Sorry, minus not 10, right? Minus 15, right? Likewise, you have some points, but if it is a dollar, so it is not possible for this one, right? Minus values, right? Maybe here I'm putting some values, let's say 58, 110. Just imagine these are some abnormal values, right? These are abnormal values, right? Okay, now we will look at how we can apply the binning techniques, right? So in this data set, there is no abnormal value, but this is not the actual thing, right? In the real world, definitely you have some abnormal values, right? We cannot use the same way if you are dealing with real data. Definitely you have some, so definitely you have some abnormal values, right? So based on the previous example, the equation in your data set, you will notice these are some abnormal values. Also, you have a scenario, we have a very less number of data set. Because of that, we cannot uh, ignore those data. So definitely we need to apply the smoothing techniques. By using the binning techniques, I need to smooth the data. Now I will tell you how to smooth or binning the data. Let's say now this is your data set. Here we have 9 records, right? Here you have 9 samples or 9 instances. You have only 9 instances you have, right? So the binning technique means, right? Binning means you are splitting the data set into different number of bins, right? Maybe you are binning into equal size bins, right? If you, maybe you can look at those things in your practical, right? If you are dealing with VECA, there are different binning techniques, right? So at that time you will understand what is that, right? So now we will look at one type of binning, mean based binning, right? Let's say to overcome these outlier values for these 9 instances, we can bin into 3 categories, right? So maybe just imagine we are uh, bin we are convert these all 9 instances into 3 bins, right? So 3 bins means, first of all, what you need to do, you need to write your data set in the ascending order, small value to the largest value. You need to write all the values in the ascending order. If you have ascending order, you don't need to worry about. If you don't have ascending order, first thing you need to convert your data set into ascending order from minimum to maximum values, right? So 4, 8, 15, 21, 21, 24, 25, 28, 34, that is already in the ascending order. That is the first step. You need to write your data set in the ascending order. Now we need to decide how many bins we are categorized, split. So we are the one decide how many bins, what is the number of data instances we have, right? Also, maybe we can apply different bins, different number of bins. Sometimes what will happen, even if you apply binning techniques, they are all the outliers are exist, right? You can understand those things in practical scenarios, right? Let's say you have some abnormal values here. You have abnormal values 300 and 500, right? Right. Now you have, let's say this is 600. Now already 9. Here you have 12 instances, right? So now what will happen? Similarly, most of the times these consider as outliers. So maybe this one considers outliers, right? So at that time scenario, this type of scenario, right, you can apply different bins. Maybe you can bin into 3, bin into 4, bin into 5. Then you will check whether which bins are perfectly matched. It means which bins they don't have any outliers. It means if you have, sometimes if you have bin into 2, you are not completely deal all the noisy values, right? It means even if you bin into 2, your noisy values are exist, right? Even sometimes you have 1,000 or 10,000 record, even if you have bin into 3 bins, the purpose of binning, you can remove the outlier values, right? But sometimes even if you bin into n number of bins, but you cannot sort it out the outlier issues. So at that type of scenarios, you can change the variable. It means you can change the instances, the bin number of bins. Then you will find out more suitable bin for your data set, right? So here just an example I'm telling you with some samples, right? So I'm telling you the binning techniques, right? So the situation where you can apply the binning technique, it's varying time to time or your data set what you have, right? So just imagine, first thing you need to write all the data point in the ascending order. Ascending order you need to write, right? It's the first thing. Second thing, you need to decide how many bins, right? Second thing, decide how many bins you are split, right? In this question, just imagine I split into 3 bins, right? So in this data set, I can split into 3 bins. Just imagine here I have 9 bins. So I can divide into 3 bins. So I can split this way. So this is my, because this is equal size for each bin, right? So if you have maybe 500 samples, maybe you can split into 5 bins for each bin with 100 samples. It's up to you, right? You are the one decide. Maybe this 500, maybe we can categorize into 10 bins with 50 instances. First, you can apply the binning techniques. Then you can check even after I apply the binning technique, is there any abnormal values are keep or not, right? So for that purposes, you can find out different binning techniques and you can find out the more suitable bin numbers, right? So if you look at here, so the first step, you can write all the data points in the ascending order. Then you can decide how many number of bins I can split the data. So in this example, I am splitting into 3. This is my second step. The next step, I need to find out the mean value for each bin. So this is my bin 1, this is bin 2, this is bin 3. So for the bin 1, I need to calculate the average value. So what is the average value? The mean value. So get the sum of these 3, 8 plus 4 plus 15 divided by 3, then 12 plus 15, 27, 27 divided by 3. So the mean value of bin 1 is 9, right? Similarly, the mean value of bin 2 is equal to 21, 21, 24, then 66. 66 divided by 3, the bin 2 mean value is 22. Similarly, the bin 3 mean value is 25 plus 28 plus 34. It is equal to 30, 50, 70, 82, 87. 87 divided by 3, that is equal to bin 3, it is 29, right? So bin 1, the mean value is 9. So now what you do, rather than you are putting these values for your, rather than you are putting these values, you can replace by with these, right? For the bin 1, you have 3 instances, they are 9, 9, 9. Here you have 3 instances, 22, 22, 22. So previously we have different data instances now. So those instances, they have abnormal values. Now we can remove these abnormal values with the help here 22, 22, 22. Here the instances are 29, 29, 29. Maybe you have a 34 is a abnormal value. Now we are reduced the value into 29. So it means we are removing the outlier. So here you have, this is your sample data points. Now you are converting your samples. So previously your range between 4 to 34, right? Now your range, now your data sets are 9, 9, 9, 22, 22, 22, then 29, 29, 29. So your range is between 9 to 29, right? So this is 30 intervals. Here you are getting 20 intervals. So it means the actual thing, you are reducing the abnormal intervals, right? So this is one way. By using the mean value, you can fill the missing values, right? Okay. Yeah, we have 10 minutes, right? Let's speed up the things. Okay, this is one type of binning techniques, right? So we are by using the mean value. This is by using the mean value, we can fill the missing values. Sorry for that. Okay, now we will look at the second type based on the bin boundaries, right? One way we can fill the missing values by using the mean value. Another way we can fill the missing values by using the bin boundaries, right? Now we will use the same data set, right? First, you can check whether data is in ascending order. Then you can split into how many bins. Let's say first we will look at 3 bins, right? Now what you need to do, if you divide into 3 bins, first you need to check, right? Okay. Now previous case, we will find out the mean value, right? The second scenario, bin boundary. So bin boundary for this bin 1, this is we can call lower boundary. This is we can call upper boundary. For bin 2, this is lower boundary. This is upper boundary. right? He similarly for this bin 3, this is called lower boundary, this is called upper boundary, right? Now what you need to do, right? Bin boundary means for each data points, let's say for the for the bin 1, right? For the bin 1, you need to check what is the lower boundary. Lower boundary is equal to 4, right? The upper boundary is equal to 15, right? Now what you need to do, each data points whether they are close to the lower boundary or upper boundary. If the data points are close to the lower boundary, you can replace that value with the lower boundary. If your data set with the upper boundary, if the data set is close to the upper boundary, you can fill with the upper boundary value. It means maybe the easiest way, you can plot in a number line. So here 4 is there, here 8 is there, here 15 is there, right? Now if you look at the first, so this is your, let's say this is your lower boundary, right? So 4 is your lower boundary, 15 is your upper boundary, right? So if you take the first data point 4, so it is exactly in the lower boundary. So for this data point, you can replace with 4, right? If you think about the second data point, that is 8, right? So now maybe 8 is here, right? So 8 is, what is the distance from lower boundary? The distance between 4 and 8, 4 units, right? If you look at the distance between 8 and 15, that is a 7 unit. So now tell me, the data point 8 is close to 4 or close to 15. It means the close to lower boundary or close to upper boundary. The data point 8 close to
Lower bound.
lower
So
boundary.
lower bound.
So you can replace this value with 4, right? If you look at the 15 last value, that is exactly the same point, right? So that is a upper boundary. So normally you don't need to check about the lower boundary and upper boundary. They are comes as a same, but the middle values you need to check whether it comes as a lower boundary or upper boundary. Now here the lower boundary is 21, right? So it is, we can replace as a 21. Here also 21, right? Here it is comes as a 24. If you look at here, the lower boundary is 25, upper boundary is 34. So now we need to check, this is a 25, this is 34. Now there is a situation, 28 is there. So just look at here. Now, there's nothing, you need to find out the differences. Here the difference is 3. Here the difference is what? 6. So 28 is close to the lower boundary. Here we are replaced with lower boundary value 25, right? So this is the way. Now our data set is converted into this way: 4, 4, 15, 21, 21, 24, 25, 25, 34, right? Yeah, very good. Yeah, very good. Who is that guy? Lahiru, yeah. Yeah, I like this type of questions, right? If you are fellow with me, you are getting this type of questions, right? I appreciate your question, right? Anyone have any questions? Tell me. So I think he's the one, 003. He's the one, he or she, I don't know. He or she, he is following what I am telling, right? That is the indication of his question, right? So he asked a question, right? Anyone have any questions? I have an answer. That is the next thing I am planning to tell. But he asked that question. Anyone any questions? What about others? Don't you have any questions if you are binning? Anyone have any questions? Tell me. What about others? Don't you have any questions? So definitely you have a question on these bin boundary techniques. What is that? Yeah, someone asked different question. 25, 26, 28, right? 20, sorry, his question. Yeah. Okay, just he asked 20, there is a bin called 25, 26, 28, right? So the local, the lower boundary 25, upper boundary 28. So here we can replace by 25. Here we can replace by 28. So here what we need to do, 26. So the distance between 25 and 26 is 1. The distance between 26 and 28, 2. So it's close to 25. Here we can replace with 25, right? So 25, 25, 28. What else?
Sorry, sir. Both sides are 1 1.
Yeah.
That time, how
Yeah, that's why I
to
asked you, right? Yeah. So yeah, this question, right? So his question is, I think he right mistake, right? Now tell me what will happen. This is his question, right? So now the lower boundary is 25, upper boundary is 27. His question, right? If you look at here, now it is in the middle of the lower boundary and upper boundary. Don't you have any questions this way? It's also possible, right? You have a lower boundary, you have upper boundary. Your data points in the middle of these two boundaries. So because the distance here 1 unit, here the distance is 1 unit. So it means exactly middle value, your data point 26 is located, right? So at that time, so first you can put this one as a 25, this one as a 27. If you have the equal distance between the data point, you are getting the minimum lower boundary as a data point, right? That is a normal procedure. You are getting the minimum, you are getting the lower boundary as a data points if that distance is equal distance. If your data points in the middle, you are consider the lower boundary as a data instance, right? That is the thing you need to remember. Okay, so that is we can call binning techniques, smooth the noisy values with the help of binning techniques, right? So the second one, the regression example, right? You have a linear equation, right? If you have a data points, right? If you have a data points, I don't know exactly, right? If you have some data points, from that data points, you can calculate a linear line, right? That is the regression model. If you find out the equation for a linear line, if you find out the equation for a linear line, that is the regression model. That is we can call regression model. I think you can learn these things in your practical session, that Excel sheet practical session. I hope you learn these things, right? So if you have a data points, from that data points, you can find out the linear line, that is your regression model. So from that model, you can easily find out the outliers. So this is normally we are using for removal, outlier removal. We are using this regression example. Similarly for clustering. So we have different clustering techniques, maybe k-means or hierarchical clustering, right? Density-based clustering. There are so many different clustering techniques, right? So by using one of the clustering techniques, we can cluster your entire instances, all the instances into n number of groups. So once you cluster and plot the data point, then you can easily, these are the outlier values, then you can easily remove these outlier values, right? So binning techniques for handle the outlier values, the regression analysis or the outlier analysis, that clustering technique, grouping techniques, that is for removing the outliers we are using, right? So the last part of data cleaning, the last part of the data cleaning is correct the inconsistency in your data. So correct the inconsistency in your data. So correcting the inconsistency mean, I will explain with the simple example. Let's say this inconsistency occur in the situation, right? The inconsistency occurred in the situation of data integration, right? Another major type of data pre-processing is data integration, right? So while you are integrate data, there are more possibilities to occur inconsistency in your data, right? So that is the situation. If you integrate the data, I already told you an example, right? There are 3 hospitals, right? They have different unit scales to measure the glucose density in their blood cells, right? So maybe they are using milligram per mole or gram per mole. On that situation, maybe you, for your research, just you are directly integrate from 2 hospitals without considering anything, right? But the problem here, hospital 1 using milligram per mole as a scale to measure the glucose density in the blood. Similarly, the hospital 2, they are using the gram per mole as a scale to measure the blood glucose level in the blood, right? If you directly integrate these two, it create inconsistency in your data. It means let's say 1.5. Just think about, okay, yeah. Okay. Yeah. 1050 milligram per mole, right? So this is one scale. So milli means that is 10 to the power minus 3, right? So another hospital, let's say, yeah, wait a minute. Okay, they are using gram per mole as a scale, right? Okay, now in hospital 1, there is a record called 150 milligram per mole, right? In hospital 2, they have a record, right? 0.15 gram per mole, right? This is one record in hospital 1. This is another record in hospital 2, right? If you are directly integrate all the records into your table, right? Your table thing may be milligram per mole or gram per mole, right? But actually, the two values are indicate the same values. Why I'm telling here, 150 milligram per mole is equal to, we can write 150 multiplied by milli means 10 to the power minus 3 gram per mole, right? So 150, 10 to the power minus 3 means we can write the negative index, 10. We know, you learn in your first years, right? A to the power minus 3, we can write 1 over a to the power 3. The negative index we are converting to positive index, right? Similarly, 10 to the power minus 3, we can write 1 over 10 to the power 3 gram per mole, right? So 150 divided by 10 to the power 3,000 gram per mole, right? If you look at here, you can cut this one and this one. 15 divided by 100, 0.15 gram per mole. The actual real thing here, both are same values, but because of inconsistency in your data, you are think this is different record, this is different record. So if you are using this type of inconsistency in your data, definitely your model perform well. Also, your model not learn in efficient way, right? So inconsistency means the same data you are using different structure or different format or different scale. Because of that, your algorithms or your models, your training models, they are inefficiently learn, right? Their learning capability is reduced because of your errors while you are integrate the data. Another example, right? Maybe one branch, they are using this type, this structure to store the purchasing behavior. Another bank branch, they are using different structure. So at the time also, your machine learning model consider this is different and different event, this is different event. But if you think about these, both are same events, right? This is also we can call inconsistency. The same value you are using in different units or different scale. Because of that, your learning capabilities of your model will reduce, right? That is we can call inconsistency, right? That's all about data cleaning process, right? I will stop here. We will continue by tomorrow evening. Maybe you can tell me the time, your free time. Don't go for after 3 or something. If possible, give me 1:30 or 1 to 3 likewise. Right. I try to complete the remaining 3 types of data pre-processing techniques. So up to now, we have discussed data cleaning. Data pre-processing have major 4 parts, right? Data pre-processing have 4 parts, right? What is that? Cleaning, integration, reduction, transformation, right? In the cleaning, we have 3 things, right? Fill the missing values, then outlier removals, correct the inconsistency, right? In the fill the missing values, we look at 7 different scenarios. Outlier removal, there are different scenarios, maybe remove or handle. If you remove, you need to find out the interquartile range equation, or maybe you can plot, right? Then we are look at the inconsistency, correct the inconsistency. Up to now, these are the things what we are discussed, right? I will start from data integration by tomorrow.